So before like exploring some other annotation that Unit 4 offers to make the code more maintainable, we are going to use something called hamcrest. And what is hamcrest for is a library that it is integrated in Unit 4. It's not included in Unit 5 because they separated after that, because like they make them like separate. If you use Unit 4, hamcrest is already there, but if you use Unit 5 you need to include the hamcrest library too. So with that in mind, like Unit or hamcrest, actually it is used to make the code more humanly readable. So you can see, for example, in this line we can read this, a programmer can understand this very clearly. We can assert, and assert equals that expect should like equals result, but it's not very readable, and in some cases can create some misunderstanding. For this case it is simple, but if you have a lot of code you may not understand something like very clearly. So hamcrest is used to solve this problem, and this tries to make the code very readable, so it clears like everything about what the test is trying to make. So we are going to implement another function that is going to make a multiplication. We already have a case of addition, so we are going to add this case right here. I'm going to copy paste this code because it's a little bit similar. We are not going to change a lot about it. So what we are going to like change here is this, like we have multiply, and it should return the multiplication. Okay, 1 second, should return the multiplication of the two numbers. So as we saw previously, we have these three steps. So we have to arrange, to act, and assert. And I need to clarify something here. We are using something called TDD, test driven development, and what this stands for is like you don't like write first the calculator class, and then you make the implementation of some function, for example the addition. But what you do is actually you write the code backward. Before like creating the class and before creating the functions, you try to understand and assert what you are trying to do first, and then you try to make things backward and create the instance if you didn't create it yet, and then you implement, like you add the function, what the function should do actually, and this helps you actually to clarify any misconception or misunderstanding of something, and with this way you read like a very solid like code, because you know what you want to do actually, and you are very precise, and in this way you are separating everything, so you have every function separated. So what we want to do here, for example, we want to return a multiplication of the two numbers, so we want to assert that this expected value equal this result, but we are going to implement something like from the hamcrest, as I said before. So the difference is going to be like that. So we have something called expect assert that. We are going to like expected, we have expected value, and this is going to equal to, and we are going to have the result. So we are going to implement that from the mature hamcrest, so this one right here. We are going to do the same thing here, so from the hamcrest too, and for this one we are going to implement it also from the hamcrest. There is some similarities, but you need to be very careful about from where you import your functions. And yes, so we can get rid of this, or before get rid of this, we are going to make a comparison. If you try to read this, you know, you can easily find the difference. We have the assert equals expected result, but if you compare to this, it's more readable. You can assert that expected is equal to result. So it helps you understand very clearly what you are doing. And what we want, we want to have a multiplication function to multiply, and we are going to have like 3 here. I'm going to make this very like in order, and this is going to be 6. Okay, so we need actually to implement this. We are going to create this function, and we are going to return the null just to make sure that everything is working. We can just test this function. So right now we will have like an error, like obviously, so we expected so is null but actual, something like that. So we are going to make the multiplication work. So 1, we are going to repeat that. So yeah, so now it worked, as you can see. So we have implemented hamcrest, the function from hamcrest library, and you can see that the code is much more easier to read and to understand.